I'm here to tell you about Cancer Data Aggregator, a tool for researchers to discover and reuse existing cancer datasets. So, why does CDA need to exist? Well, finding data is hard. We typically read lots of journals, then we read the data citations in those journals and go see if we can find the data wherever it was deposited. And once we found it, it's not always the format that we need, or it might not have the variables we were expecting, or there might be some other reason that it doesn't quite fit our criteria. And finding data shouldn't be this hard. At CDA, we're going to flip this model on its head. We're doing cancer focused, so all of our data comes from National Cancer Institute funded studies, and it's data-centric search. So we're searching the data directly, and then later you can go find the relevant journal articles for the data that actually fits your needs. And our data is aggregated. So no matter where that data was deposited, if it's in one of the repositories owned by the National Cancer Institute, you can search it using CDA. We have made petabytes of data, thousands of patients, hundreds of studies across 5 data commons, searchable from one interface. So how does CDA do that? Well, first we go to each of the different repositories and we pull as much information as we can about the different data sets and patients that they have information about there. And then we heavily cross-reference it. So we do things like make sure that if a patient was in more than one study or has data at more than one data commons, they are linked and you can find everything about that one patient under a single ID. And then we harmonize. So we take every term and every value for those terms and we align them so that you can search without listing every synonym for your disease or listing every possible way to specify that you want male patients. And then we host the data. So all of this metadata can be searched via our website, Python library, and API. Currently, CDA has data from 5 sources. Those are the genomic data commons, the proteomic data commons, the imaging data commons, the integrated canine data commons, and the general commons. From their names, you can probably guess what kind of data each of these house, but this means that CDA lets you search across all sorts of genomic data, RNA-seq data, mass spectrometry data, radiology and pathology slides, data from dogs that have naturally occurring tumors that are similar to those in humans, as well as other data types that don't fit those categories. And at CDA, data comes first, which means that CDA makes it possible for you to search using the variables that you care about. You can search by subject traits such as age, sex, race, ethnicity, or vital status, or by clinical variables like cancer type, stage, grade, anatomic site, or age of diagnosis. You can search by all sorts of treatment and testing variables, such as what drugs or radiation therapy a patient was on, what kind of imaging they have, or what kind of sequencing and proteomics testing they had done. And if for your use case, you know that you really need a specific type of file, you can search directly on the data characteristics, such as the file format, the data type, or access restrictions. At CDA, we want to make data reuse available for every user, so we offer multiple ways for you to interact with our database. If you're a typical user who would rather browse a website than use an API, you can use the interactive tool on our website to search every subject that we have data for in CDA across a handful of the most popular terms, such as anatomic site, diagnosis, treatment, ethnicity, race, and age. For our more computational users, we have a Python package that allows you to easily interact with our database without using the API. And the Python package comes with both low-code and no-code options. For instance, we've made a collection of IPython notebooks that are pre-populated with popular searches. And you can use any of these notebooks either as is to rerun the searches that are demonstrated on our website, or you can easily change any of the variables inside of these searches to make them your own. All of this runs on Google Colab, so you don't have to download anything at all. And if you get stuck, you can use our CDA Mad Libs IPython notebook, where we've taken all of the different search variants and turned them into easy fill-in-the-blank boxes. For our most advanced users, CDA has a RESTful API that you can use without using the CDA Python module. Instructions for this are also available on our website. All of these options are available right on our website so that you can choose the mode of CDA that works for you today. And best of all, CDA is free and open. Search in CDA is always free and downloadable. All of our code is open source so that you can see how we've made this work, or you reuse our code for your own work. And CDA is open access. While many of the files that you'll discover using CDA have restricted access, all of the information that we use to allow you to search is open. That means that anyone can come search with no special permissions and no data access agreements. You can find everything no matter who you are. So come try it for yourself. You can find us at https://cda.readthedocs.io, and I hope to see you there.